As erosion continues, the machine controls advance the electrode through the work, always maintaining a constant gap distance between it and the workpiece. To understand how EDM removes metal, let's examine a single spark in the erosion process. As a pulse of DC electricity reaches the electrode and part, an intense electrical field develops in the gap. Microscopic contaminants suspended in the dielectric fluid are attracted by the field and concentrate at the field's strongest point. These contaminants build a high conductivity bridge across the gap. As the field's voltage increases, this material in the conductive bridge heats up. Some pieces ionize to form a spark channel between the electrode and the workpiece. At this point, both the temperature and pressure in the channel rapidly increase, generating a spark. A small amount of material melts and vaporizes from the electrode and workpiece at the points of spark contact. A bubble composed of the gaseous byproducts of vaporization rapidly expands outward from the spark channel. Once the pulse ends, the spark and heating action stop, collapsing the spark channel. Dielectric fluid rushes into the gap, flushing molten material from both surfaces. This EDM residue consists of small solidified balls of material and gas bubbles.